it's being hard to slide when it's not moving versus once it starts sliding, it gets easier. There are actually two different mu's. There's mu there's the static and the sliding. I'm trying to think of the Alex, help me here for a second.
Dynamic?
Yes. Mu S and mu D, the static and the dynamic.
Maybe kinetic.
Is it kinetic?
I think they go by...
Different textbooks, different ways. UK. And almost always the static coefficient of friction is bigger than the kinetic coefficient of friction. These are, common values are in this 0.2, 0.5 range. So, like this one has a pretty low coefficient of friction, and it's always defined as between two different things. If I slide this on this table, it's going to be different than if I slide it on the floor. So it's defined between two different surfaces. My hand slides one thing on here, my hand slides different on the concrete. Concrete's going to be stickier than on here. Likewise, the concrete on here would be different. So it's always between two different devices, two different mediums. The funny thing, I find funny, what's missing from this equation to define friction that kind of seems like it might ought to be there? If you want to make something that had a lot of friction, a lot of traction, what would you, and how would you make it?
Rubber.
You might make it rough, so you might include some texture. But that texture, that you're kind of looking at trying to change this coefficient of friction, or you might make it kind of sticky, rubbery, something like that, versus slick. If you want to make something really slick, you can lubricate it, reduce the coefficient of friction. But what else would you do?
Surface area.
Surface area, yeah. Like you think of the dragsters, these big tires in the back end of it. This equation doesn't work for every situation. It works for most of them. It doesn't generally work when things are very flexible, like a car tire, where they can actually rip down into the ground. They don't necessarily work for tires when they're gripping, especially on earth, because they're digging and tearing. They work best when everything is rigid, very rigid. When things start bending, the equation kind of fails. And there's other sets of equations. So this is kind of a basic one for rigid objects sliding upon one another. And there is no area. So based on this equation, if I took this eraser, assuming this side is the same, it should slide as far that way as that way as that way, if I can get it to stand up. Because the area doesn't matter. It's the normal force and the coefficient of friction. Area is not a player. That doesn't seem intuitive to me, but it generally works out as long as the items are fairly rigid. Any questions for this? We'll do some more of this. I think I've given you enough to be dangerous with for your lab you're going to do today. You ready, Alex?
Think so.
Okay. Alex is going to go from here. Anybody else got homework?